So this is a water current sensor, and it's set to measure vertical current. You can see that as there's a little bit of motion, the DC motor will turn and output a voltage, either positive or negative. So when you get the sea perch to the level that you want, you let down the anchor, and then you secure it. You can see that even with other water currents, the sea perch is going to stay at the level that you want it. To measure water current, we are going to use a small 1.5 volt DC motor, and we need to prepare it for waterproofing, similar to the sea perch motors. We're going to use a fan blade that has set screws to attach to the motor so that when it spins in one direction, we will have a positive voltage and a negative voltage in the opposite direction, so that we can tell which direction our current is flowing. The fan blade has been slightly modified so that it is a little more flat than it originally was, so that it turns more quickly with low speed water currents. Okay, the propeller blade is super glued onto the shaft. The motor is waterproofed inside of a film case, similar to the sea perch motors. And the wiring runs inside of this PVC. The PVC allows it to distance itself from the sea perch. The thermocouple wire had to be waterproofed. I used hot glue on the ends, wrapped it with tape, and then hot glued around the outside of the tape to seal it. I also hot glued the wiring at the back, but inside of this tube it's also waterproofed because the back of this has been hot glued as well. Okay, this sensor is set up to take measurements on its own for testing, which is the only reason why this fin is on there, to stabilize the body of the shaft. And as the blade spins, even if it spins slightly, it will measure a voltage change. Even just this much spinning will measure a voltage change. And we also have a thermocouple wire set down, and it's hard to see, but right here is the thermocouple. This is our data collection tool. This is a LabQuest from Vernier, and this has 4 ports. Right now we're using 2 of the ports, and as you can see, it will measure a voltage change with a slight difference in the blades, and also the temperature is very sensitive. So as we pass through different temperatures of water, we will be able to measure their temperature and see if there's any current flowing, any water current up or down, and it will log that data for us. These are connected to with their wiring just to an extension cable so that it can be used underwater. So here we have our data that we collected, and we can pick a point It will tell us what our voltage is at that point. We can export this into Excel and calculate the time that it took to ascend and descend and the average voltage.